Let's say that I knew that the point 4, 3 was on the terminal arm of my angle theta. So let's draw this. So our initial arm would look something like this. And I hope I can get this through there. We have a point. That's a point 1, 2, 3, 4, 1, 2, 3. So right there, there's the point 4, 3. And we know that our terminal arm goes through that point. Oh yeah, that's not bad. Kind of goes through there. There we go. Now, so this is our little angle theta here. It's also our reference angle because it's less than 90 degrees and the angle between the terminal arm and the x-axis. So let's say I wanted to find out what would be the sine of that angle and what would be the cosine of that angle and what would be the tan of that angle or the tangent of that angle. Well, if I take my little point here, 4, 3, and I drop a perpendicular down to my x-axis, then I've made a triangle out of the terminal arm and the initial arm. And so what I've got here now is I've got a side length here of 4 because x is 4 and y is 3. So now I can come up with the tangent ratio because I have the opposite side 3 and the adjacent side 4. So the tangent ratio would be 3/4, opposite over adjacent. What I don't have is my hypotenuse. However, I can find out what my hypotenuse is because I have these other two sides. So a squared plus b squared equals c squared. So 4 squared plus 3 squared equals, c squared. This would be 16, this would be 9. 16 plus 9 is 25. So taking the square root of both sides to get c, I've now determined that the hypotenuse is c. And so now I can find the sine ratio. Sine of angle theta would be 3/5, opposite over hypotenuse. And the cosine ratio would be adjacent over hypotenuse, 4/5. So you can see that in quadrant 1, all of the trig ratios, sine, cosine, and tangent, are all positive because all of the sides of the triangle are positive. Now let's look at what happens when we go to quadrant 2. Say we had a point in quadrant 2. Let's make this -4, 3. So let's do this point right here, -4, 3. What happens here? So this would be our new terminal arm. Come on. There we go. And now when we draw our perpendicular down to the x-axis, so here's our little reference angle here that we're working with. The x value is -4 and the y value is 3. And notice when we do the hypotenuse that that's still going to be +5 because it's the length of this side, or sometimes we call this side length r. So x is -4, y value is 3, and the hypotenuse is 5. So now if we're looking at the sine, cosine, and tan, sine is opposite over hypotenuse, so that's going to be 3/5. The cosine of the little reference angle here would be -4 over 5, and the tangent of that angle is going to be 3 over -4. So the only thing that's positive now that we're in quadrant 2 is sine. Sine has a positive ratio, but the other two are negative. And that's because of this side, the y value is going to be positive in this quadrant, and sine is y value, opposite side over hypotenuse. Watch what happens when we go into the third quadrant. So just say we had an angle in the third quadrant. You could see here that our x value is still going to be something negative. Let's move this -4 into this other triangle. But you can see here that x is definitely going to be a negative x value. The y value is also going to be a negative value because it's going down. And then we have our hypotenuse, or sometimes we call this r, is positive. Hypotenuse, or r, is always positive. So in this quadrant, if you looked at sine, the sine of our reference angle would be opposite, negative, over the hypotenuse, which is positive. So this ratio is going to be negative. If you look at cosine, cosine is adjacent, negative, so a negative x, whatever that length is, over r. But tangent is opposite, so a negative y value divided by a negative x value, which is actually a positive, because a negative divided by a negative is positive. So it's the tangent ratio that ends up being positive in quadrant 3. And if we were to draw an angle in quadrant 4, and let's say we had just some point in there, so we dropped it down, and so here's our little reference angle here. Well, here on this side of our triangle, this is going to be a positive x value. The y value is going to be negative because it goes down, and the hypotenuse, or the radius of our circle, if you imagine a circle going around here, is positive. So sine of this reference angle in the fourth quadrant would be opposite over hypotenuse. That's a negative ratio, negative divided by positive. Cosine is positive x over positive r, so this is positive. And the tangent ratio is opposite over adjacent, which is a negative ratio. So it's cosine that's positive in quadrant 4. So in quadrant 1, they're all positive because all of the sides of the triangle will be positive. In quadrant 2, it's the sine that's positive. In quadrant 3, it's the tan that's positive. And in quadrant 4, it's cosine that ends up being positive. So this can all be summarized this way. So in the first quadrant, all of the trig ratios are positive. In the second quadrant, it's only sine that's going to be positive. In the third quadrant, it's only tan that's going to be positive. And in the fourth quadrant, it's only cosine that's positive. And we need to know those things, and so we could always draw the triangles and look at the ratios and figure it out. But a little quick way to remember it is this little saying: all students take calculus. And so all in the first quadrant are positive. S for sine is positive in the second. T for tan is positive in the third. And C for cosine is positive in the fourth. So if you just remember that little saying, all students take calculus, you'll know which quadrants the trig ratios are positive in. So let's see why this is important when it comes to solving some trig equations. So let's say I know that sine theta is equal to root 3 over 2. So I have my ratio. This is my ratio here. So specifically, this is the opposite side, and the denominator here is the hypotenuse, because sine is opposite over hypotenuse. So we have the ratio, but we want to know what the angle is. Well, this is where the ASTC comes in. All students take calculus. This is a positive ratio, so sine is positive here. This is a positive ratio. So I know that somewhere in this quadrant here and somewhere in this quadrant here, I am going to get an angle. And if I dropped a perpendicular down here, I could make a triangle in this quadrant where the opposite side is root 3 and the hypotenuse is 2, because this is a positive y value and this is a positive hypotenuse. So this is one possibility. I could have one angle there. I could also have another angle I'll call this R2, reference 2, in this quadrant. Because over here, this side could be root 3, and this side could be 2. And this would satisfy that ratio. Opposite is positive root 3, and hypotenuse is 2. So the question is, what would that angle be? Well, you should have learned your special triangles, and you should recognize that root 3 and 2 are two of the sides of this special triangle, where this angle here is 60 degrees and this angle here is 30 degrees. So what I'm going to look for now is what that reference angle is. What would that reference angle be so that when I take the sine of it, I get root 3 over 2. So I'll start with 30 here. But the opposite side of 30 is 1. So this angle is no good because the sine of 30 would be 1/2. So I'll check 60. The sine of 60 would be root 3 over 2. Sine 60, root 3 over 2. So I now know that the reference angle should be 60 degrees. So looking at my little sketch here, if I know that this is 60 degrees and I know that this is 60 degrees, then to find out what theta is, I've got this answer here, which is 60 degrees. So I'll say angle 1 is 60 degrees, because remember, we are measuring from our initial arm. So our initial arm was right here. So we're measuring from here, so we want this angle, which is 60 degrees, and then we also want this one, because this would be the angle theta to get to our terminal arm over here. So this second answer, how am I going to find that? Well, I know that this is 180 degrees all the way to here, and this little reference angle we found to be 60, so my second solution is going to be 180 degrees minus 60 degrees. And of course, that's 120 degrees. So there's two solutions here. The first one is 60 degrees, and the second one would be 120 degrees. Let's look at another example. How about cosine theta equals 1/2? Okay, so this is a positive ratio. So I need to figure out where is cosine positive. So cosine would be positive in the first quadrant, so I know I'm going to get an answer somewhere between 0 and 90 degrees. We don't know where yet, so just draw an angle in the middle here somewhere. Sine is positive in this quadrant, so that means cosine would be negative there, so that's no good. Tan is positive in quadrant 3, so cosine's not going to be positive there, but cosine's positive in quadrant 4, so I'm going to find another answer there, somewhere between 270 degrees and 360 degrees. So we need to find out what that little reference angle is. So let's go to our triangle again, and it's this same one that we did last time, because it's the triangle that has the 1 and the 2 in it. So this is 60 degrees and this is 30 degrees. So the cosine of something is 1/2. Is the cosine of 30 1/2? No, that would be root 3 over 2. The cosine of 60 1/2? Yes, cosine is adjacent over hypotenuse. So my little reference angle here is going to be 60. And that means this little reference angle here also is going to be 60. And now we need to simply figure out what our angles would be. So we're measuring from the initial arm, so the first answer will be this one, which of course is the exact same thing as our reference angle. So one solution will be 60 degrees. The other answer would be all the way around here till we get to the next terminal arm. And so we have to figure out what that big arc is. Well, we don't know what that big arc is, but we know that if we go all the way around to here, that's 360 degrees. And then minus the 60 that we didn't quite get to, because that's the little reference angle there, means that big arc that we're looking for, measuring from our initial arm, this would be 300 degrees, because 300 plus the 60 would give us 360. And so these would be our two solutions. cosine of 60 is 1/2, and the cosine of 300 degrees is 1/2. So we have our two solutions. Let's look at another example. About tan theta equals -1. So first step, determine which quadrant our angles are in. So they're all positive in quadrant 1. Well, that means tan's not going to be negative in that first quadrant. Sine is positive in quadrant 2. So if sine's positive here, that means tan must be negative. So there will be an answer somewhere in that quadrant. In quadrant 3, tan is positive. That's not going to work there because here tan is negative. And in the fourth quadrant, cosine is positive. So tan must be negative. So there'll be another answer somewhere in here. Now, usually we want a ratio, like an opposite over hypotenuse thing. So -1 as a fraction would be -1/1. And in this triangle, the 1, 1, √2 triangle, where this was 45 degrees, so this was the other triangle you need to remember. This is where it's all kind of coming together here now. This is where we get a ratio of 1. Or in this, the signs are just going to be determined by the quadrant. So we really have a ratio of 1/1, which is what we get when we take the tan of 45 degrees, opposite over adjacent. So we know our little reference angle is 45 degrees. So these are the little reference angles here. But we always measure theta from here, from 0 degrees. So we're looking for this answer right here. That would be our first terminal arm. I'll call that θ1 for my first angle. I know all the way to here is 180 degrees, so this would be 180 back up 45. So 180 minus 45, which is 135 degrees. So there would be my first solution. My second solution would be to get to this terminal arm. I'll call that θ2. And to get to that one, all the way around would be 360 degrees. But we need to back up 45 because we didn't quite make it all the way around. So this would be 315 degrees. So these would be our two solutions between 0 and 360 degrees. So let's summarize how we can solve for an angle given the ratio. So the first step when you're given an equation like cos x equals -√3/2 is to determine which quadrants your solutions will be in. So here, where is cosine negative is the question. Well, not here because everything's positive. Let's write these down. Here, yes, because sine is positive, so cosine must be negative. So we get one there. And in here, tan is positive, so cosine must be negative. And in here, cosine is positive. Well, that's not going to work there because we have a negative. So in this one, we would say in quadrants 2 and 3 is where we're going to have our solutions. So that's somewhere between 90 and 180 degrees, and somewhere between 180 and 270 degrees. The next thing we need to do is look at our reference angle, and we've got some special triangles that we can use. So this one comes under the 1, 2, √3 triangle, where this was 60 degrees and 30 degrees. So it looks like the reference angle to get a cosine ratio of √3/2 would be 30 degrees because cosine is adjacent over hypotenuse. So the reference angle would be 30 degrees, and I would put that here on my graph. So I now know what those reference angles. And once I have my sketch done, then step 3, from my diagram, from my sketch, I can find the angles measured from the initial arm. So measured from here, I want this one. I can get that. I'll call that angle 1. That would be 180 minus 30 degrees. All the way to here, back up 30. So that's 150 degrees. And my second answer would be the one that would go to this terminal arm. And how can I get that? Well, I know to here is to 180, and I need to do another 30 degrees, so that's 180 plus 30 more degrees. That's 210 degrees. So that's how we use um, the trig ratios and a little sketch to determine the angles. What if we have to solve an equation where we don't have a ratio that we have in our triangles? So we could get as far as step 1. So this is sine is a positive ratio, 0.6 is positive. So I know I'm going to have one answer here in quadrant 1, and I'm going to have another answer here in quadrant 2, because this is where sine is positive, here and here. But I don't have a triangle that has 0.6 as a ratio in it. So the only way we can do this one is we can go to our calculator. So the inverse sine, if I were to isolate theta here, I can take the inverse sine of both sides, and I would get theta is equal to the inverse sine of 0.6. So I'm going to go to my calculator. I'm going to first of all make sure that this, come on, shift key. There we go. You want to make sure that your calculator, when you go down to angle, is in degree mode. Mine's in radian mode, and we're not using radians yet here, so we're going to make sure that that's in degrees. And now I'll go shift sine 0.6. Now the calculator is not going to give us an exact value, so this is where we're going to have to approximate this, round this off. So we'll say we'll go to 2 decimals here, 36.87. 36.87 degrees. And so that would be this angle right here. The calculator will give you the angle that's closest to 0. So it'll find this one, 36.87 degrees. So this would be one of the angles we're looking for. But we also want to find this one here. Well, because the reference angle is 36.87, the reference angle over here will also be 36.87. And so if I want to find my second one here, I can say angle 2 is 180 degrees minus the 36.87. And for this, I'll go to the calculator. 180 minus answer. And I have 143.13 degrees as my second solution. So using the calculator, instead of going to the special triangles, the calculator is going to give us one of the angles there. Let's look at one more calculator type example. Cos x equals negative 4/5. So cosine would be negative here and here. And 4/5 is not one of our ratios from our triangles, so I'm going to need my calculator here, and I go inverse cosine of negative 4/5, and it gives me 143 degrees. So I know that this angle here is going to be 143 degrees. That's what that is, because this is 90 here and this is 180. So notice here the calculator doesn't give us the reference angle. It always gives you the angle theta between your initial arm and your terminal arm, the one that's closest to 0. So it just found this one, 143 degrees. So I know that this angle here will also be 143 degrees. And so now, using my diagram to find my angle theta, I want this one here measuring from my initial arm. So that's 143 degrees. And my second solution would be measuring from here all the way to this terminal arm. And I know that all the way around here is 360, but back up 143 degrees. So 360 minus 143 would be 217 degrees. So that's how we can solve now for theta for any angle between 0 and 360 degrees given any ratio.